Let's record this. Okay. Yeah. So OSI, it's basically to improve the way the engineers work or how they are working on a specific problem or a specific issue, or if they want to solve something, what is the plan of action they have to follow is what the OSI model is all about. So if I'm gonna do this like a layered model, so let's say there is a big project. I don't know why other people names are showing here. Give me 1 second. Let me figure this out.
I think that is everybody's mouse pointer.
Yeah. I just did all participants can view. So let me change that. Yeah, I don't want that. Okay. No. Okay, I'll figure that out later. I don't want to waste the time. Okay, so in this case, we are talking about fixing a problem or resolving a problem, right? So let's say there is a big task, right? So how do you want to fix it, right? So you divide the problem into multiple stages and you fix it. Similarly, let's say there is a big problem, like let's say there is a user and that user is trying to go to yeah, let's say they're trying to go www.cisco.com. So this user is trying to go to cisco.com, but he is unable to get the response back out of Cisco because we don't know the problem yet. So to resolve this problem, to resolve why a person not able to connect to cisco.com is a big problem, and to separate that problem into multiple smaller chunks, we create layers out of it. So there are 7 layers of the OSI model. So I can't type. Okay. Let's come off. Right. Physical layer, data link layer, and then network layer. There is transport layer, and then session layer, and presentation layer, and then application layer. Right? So what are these layers are all about, right? When the user is trying to go to cisco.com, he has to pass through all these layers to see the actual data on his laptop. If I'm trying to go to google.com to see the picture on the google.com, I have to pass through all of these layers to see the content of google.com. So if I am not able to ping means I'm asking Google, hey, Google, are you alive or not? For example, how do I, sorry, first day is always problem because you have to figure out a few stuff. So give me 1 second. Yeah, I cannot share the screen for some reason. I can only do the whiteboard. I cannot share my screen at all. Okay, that's fine. Um, so we were talking about a person going to cisco.com, right? So let's say that person is connected to his laptop, and his laptop is connected to, let's do this. Uh, his laptop is connected to with a cabled wire to his PC. That PC is cabled to the router. In this case, maybe you might be on the Wi-Fi, right? But let's say it's a hard-coded RJ45 jack cable, and that router is connected to the end of uh, through the wall. It goes to the end of street. It goes to a bigger pole, which has the AT&T router or any of the provider router, and that router will be connected to the ISP at your ISP is the service provider, right? At the hub, and that ISP is connected to the actual Cisco server, which is hosting the application cisco.com, right? So this is all physical cabling. So this is a wire, this is a wire, and this is a wire, and this is a wire, and this is a wire, right? So it's all physical cable. What if a link is broken here? That relates to a physical layer problem. So if something at the physical layer broke, we know that there is a problem at the physical layer. So then, if let's say this wire is broken, you cannot go past beyond this router because there is no more connection to go to the your AT&T router, which is at the end of your street. So to identify that, there are different mechanisms. We can send the logs from the router to you, knowing that this interface went down because a cable went down, right? So to identify that kind of problems, we enable logging. We'll make sure that the physical layer is all up and running. You turn on the logs, just like, you have maybe a Google Drive in your phone that your memory is getting full. You will get an alert saying that, hey, you don't have any storage space, increase your storage space, right? You get a message. Similarly, this router, when you turn on the logging, when it go down, the router will notify me saying that, hey, this interface went down. So I know it's a physical layer problem. So to identify that kind of issues, it could be an interface problem, a cable problem, a patch panel, an SFP. I mean, these are all network terminologies that you will get to know, right? More. It could be any of the physical layer optic problem. It could be a single mode, multi-mode fiber. I think some of you coming from an electrical background, multi-mode, single mode, core cladding, how they prepare. I think you might have heard those words if you're coming from an electronics background like that, right? So those are all kind of cables that you will learn in the physical layer. And then what is a data link layer, right? So data link layer, the name itself says that it passes the data in terms of ones and zeros. It's all bits. So when you send the data, mean like whatever you're seeing, let me pause there. Kola Manogna, can you tell me what happens when the router link go down? How will the user know?
Uh, Hi, but I'm new to this networking. This is my first class. So I guess I'm not the right person to answer, and I'm not sure what's the answer is.
Thank you. Uh, I'm not satisfied with that. I think my understanding is this is a brand new course. This is the first class. Everyone is treated like a newbie here. So whatever I say does not need any of the previous experiences or previous knowledge. So everyone is the right person here, and we are not thinking of someone you have network knowledge. So please be very attentive. I just asked a question which I told 2 minutes back. So my class will not be something that moves on, and don't think that you're just passing the day or 1 hour without getting knowledge out of it. Please don't do that. We don't want that kind of classes here. If you are not understanding something, please do your homework, get well ready to what you're going to listen in the class. I don't know, Manogna, but that is not what I expect. Please be ready when I ask the question. You have to be answering because I'm asking something which I just told now. Okay, let's move on. The data link layer. The data link layer is something that it is passing the data from one device to the next device. In this case, when a PC or the router, when they pass the data, they pass in ones and zeros, which are called frames. So you might know that if I pass a name, Ravi, my bits will be converted into, my alphabets will be converted into bits, ones and zeros, and that will be passed, right? So these are all have to be converted from whatever the context we are seeing to bits, and that bits will be passed from one machine to the other machine. So if there is a problem in the data link layer, that means that there might be a problem on a device which is forwarding this data. It could be a layer 2 switch, or it could be a device which is forwarding like a hub, or it could be a PC, or it could be a firewall as well. So every bit that I'm going to send, like this person going to send, will be converted into ones and zeros, and every device has to forward the data until it goes to cisco.com. So what is data link exactly? Data link is something that will help to connect two devices by passing ones and zeros to communicate between them. So if your device is not forwarding the frames, that means that there is a problem in the layer 2. For example, let's take two switches. This is switch 1. This is switch 2. There is a PC1 here. There is a PC2 here. Let's say PC2 has a movie. Let's say a brand new movie, right? Maybe any movie, like let's say Titanic, right? This PC2 has Titanic movie, and PC1, I'm sitting here. I want to watch Titanic on my PC, right? So I being a user, I have a PC1. I know the Titanic movie is stored in PC2. I want to see it from my laptop. What I'm going to do is I'm going to send my request over the switch 1, switch 2 to PC2, but that request will be converted into ones and zeros. And this PC2 will respond back, sending all the movie into ones and zeros to PC1. So how does the switches know? Are we seeing movies or data, text messages? Nothing. They don't know. They don't care about what they are. It just ones and zeros for the switches. They just forward the data between them. If there is a problem, if I'm not receiving the data, even though the links are up, then you might log into the switch, see why the switch is not passing the data even though the links are up. Those kind of issues will be tackled on the data link layer. So when the physical layer is good, still if the data link is not working between the devices, the data transmission is not happening properly, then we have to think about the data issues. Is that an issue with the data link, or is that an issue with the physical layer? Okay. Next up is network layer. As you guys know, network layer is all about IP addresses, right? So what is an IP address, right? So to indicate a specific device in a, I'm sorry. Did someone try to answer what is an IP address? Never mind. Okay, cool. So an IP address is allocated to a specific device in a network. For example, this PC that I was talking earlier, it is identified in the network with a specific name, right? My PC has an IP address of 1.1.1.1. So to identify a specific PC in a network, there is an IP address. And what is a MAC address means? MAC address is to identify a specific device with its vendor. When you ask someone, what is your laptop? They will tell you, I'm using a Mac. If I ask someone, what is your laptop? They'll tell they're using a HP. But how will the PCs know? How will the network devices know their make and their model? It's because of the MAC addresses. They will be identified with the vendor and the make, whatever they are doing, right? They define a MAC address for it. We as persons, we know that I'm using HP, I'm using Dell, I'm using MacBook Pro, like that, we know that, but the PCs doesn't know. So to identify that, every device will have a MAC address, which is hard-coded from the vendor itself, right? But an IP address can be interchanged. For example, if I use an IP, if I use a PC in my personal network, in my home network, I might get a different IP. Then I move my machine to a corporate network, I get a different IP. So IP address will change from network to network, but the MAC address is constant, that is defined by the vendor. You don't define it. The vendor, when you purchase it, will have a MAC address associated with your machine. So the MAC address is basically to identify the device. Okay. Bhargav Reddy, can you tell me the difference between IP address and the MAC address?
Yeah, Anna. So according to me, the IP address is given to the network, and the MAC address is given to particular PC.
So you're there, but you're not there. So far, too close. So an MAC address is an hard-coded address that is given to a device, right? So let's say there is a PC here, and that PC has a hard-coded MAC address as A.A.A.A. So you take this laptop to maybe Europe for a trip. You sit in a coffee shop, you're drinking coffee, your MAC address will never change. That is still the A.A.A.A. But this laptop in your home, you will have 1.1.1.IP, let's say that. You take the same laptop to in Europe in a coffee shop, your IP address will not be 1.1.1. It will be something that's local to that network, maybe 2.2.2.2. So in each network, your laptop IP will be changed, but your MAC address will stay the same. That is hard coded from the vendor. So that's about network layer. So what is the problem with the network layer, right? So for example, PC1, PC2, same example. They both want to communicate between them. For example, you have an PDF file that you wanted to move between the PCs. If you're not a network engineer, what will you do to move a file between the PCs? Like you're a student or you're brand new to networking, what will you do to move a file from one PC to another PC? What you're gonna do? Let's say, Rajesh, can you answer that?
Like we use pen drives or something like
Yeah,
that.
pen drives or any other hard drives to move data from one device to another device.
Correct, right? So you just
Yeah.
use a drive to move, or what you're gonna do is like you're gonna send an email,
Yeah, okay.
or simply you're gonna put in a place where both can access, right? That's what
Yeah,
a
yeah.
normal person do.
Mhm.
But you as a network engineer, to make them communicate, you can be on the same network and then do a network share. You don't have to use a USB drive. You both can connect to same Wi-Fi, and you can do a network share between them directly, like an NFS protocol or something, or an FTP or TFTP or SCP. These are all protocols that are used to transfer the files in the same network. So the reason why I brought the topic is, if there are two PCs, if they're in the same network, when I mean same network, same subnet, meaning like, let's say, I think that is too early to understand the subnetwork concepts, but let's say uh, they both are in the same location. For now, let's say they're in the same location and they're connected to the same Wi-Fi router. Let's think that, okay? So in that case, this PC will know the MAC address of this PC, and this PC will know the MAC address of this PC. So they both can communicate using the MAC addresses itself. Because they are part of the same network, this PC will know the MAC of this one, and this PC will know the MAC of this one. They don't need an IP address to communicate between them because they are part of one network. Let's say there is a PC, and there is a PC, and there is a PC1, okay? Let's say this is Rajesh, this is Venkat, and this is Bhargav. Let's say Rajesh and Venkat are friends. They want to share their files between them, right? They want to share the files between them easily. But they have Bhargav, who is their friend, but they don't want to share all the files, so they will put them in a different network. In this case, these two persons will have one set of IP addresses, and this third person will have a different IP address. To make them communicate between them, we need IP addresses. So 2 laptops, 2 persons within the same network can talk directly between them without an IP address. They can communicate them by learning their MAC addresses. But 2 persons with different networks cannot talk directly between them, even though they are in the same even though they are in the same location, they cannot talk directly between them because their networks are separate. They need to have a network device like a router to make them communicate between them. I'm going to repeat one more time. 2 persons or 2 laptops or 2 machines can talk between them if they are in the same subnetwork or same network. 2 persons in different networks cannot directly talk between them because they are in 2 different networks. They cannot directly communicate using the MAC addresses. They need IP addresses to communicate between them. That is like a thumb rule. Because it is a thumb rule, let me ask you this. So there is a PC1, there is a PC2. The PC1 subnetwork is 1.1.1.1. This is 1.1.1.2. And there is a PC 3.1.1.1. Monica Adicherla, how can I make 1.1.1.2 to communicate to 3.1.1.1? How can I make them communicate?
Can you repeat the question, sir?
How can I make 1.1.1.2 communicate with 3.1.1.1? How can I make them communicate?
Yeah, like, can I say?
Yes, let's pass on. Yeah. Yes. Whoever wants to say.
Like, because they are on different networks, so we need IP address, I think, yeah.
Yes, you need to have an IP address. Yes, you already have it, but
Yeah.
Through
they are
the
not
router.
Let me know, like
Through
they will be
routing.
connected
Through the
to
router.
same network.
Yes, someone told that we need to have a router. Yes, that is
Okay.
correct. That's the right answer. So you need to have a layer 3 device, a network device, to make two networks to communicate between them. So how do you make these two communicate? Now let's give the chance to Varun Pola. How can you make 1.1.1.1 to talk to 1.1.1.2 in the same network? How
We
they can?
need, I think switch is enough to come.
Correct.
I mean,
Perfect. Nice. So when they are in the same network, just a switch is enough. A layer 2 device is enough. But when they are in two different networks, you need to have a router to make them communicate.
So in this case, a router is called as layer 3 device.
Yes, correct.
Okay.
A router is a layer 3 device which can connect two different subnetworks. I mean, don't get me wrong, there is a layer 3 switch as well. A layer 3 switch, they came up with a concept called layer 3 switch, which incorporates the concept of router into the layer 3. But I don't want to confuse you. Let's move that aside. But a layer 3 device is needed to communicate between two different networks. That's good enough. So the next is transport layer. Let's check on the time, 9:42. Okay. A transport layer, it's a funny thing. A transport layer is basically will send the data and then checks whether the other side received it or not. That's what the transport layer does. For example, it's just like me, right? I'm bugging you guys. Hey, are you hearing this? Are you listening to me? Please repeat the answer. I'm bugging you every time. So I'm always trying to check with my student whether he's listening or not. So I'm being a transport layer here to you, whether you're listening it or not. That's what the transport layer does. When I send a packet from PC1 to PC2, PC1 will always check, hey, did you get the packet? When PC2 say yes, it will send the next packet. When PC2 say no, when the PC2 does not respond back, it will send the packet again back to make sure the PC2 sends an acknowledgement. So it is called SYN packet and acknowledgement packet. So PC1 regularly sends SYN packet to make sure that the PC2 responds back with an acknowledgement packet. So when I send a file, me being a client, meaning like, let's say I wanted to go to Amazon.com and buy a small flower for my kid, right? So I want to buy a small flower for my kid. So I go to Amazon and say that, hey, did you get my packet? Did you get my order? Amazon says, yes, here is your order. So there is a synchronous packet and acknowledgement packet. I make sure that I buy that flower and give it to my kid, right? So in that case, I always follow up, meaning my PC will send the data to make sure that it is a reliable communication. That's why if you see, when you're making any purchase, right, you will get a window saying that please do not refresh your browser. We are making your payment. there is a small buffer going on in the background. You will see that kind of message coming because we don't want your transaction to get lost in the middle of the network connection. We will make sure that your connection is successful. Until then, don't refresh your browser. Otherwise, your connection will be broken. So those kind of things will happen in the background. The SYN and acknowledgement will happen. So that's what the transport layer does. Then what happens? There is a small difference here. There are two kinds of transports here. One is TCP and one is UDP. Because I want my transaction to be very successful, I keep on checking the data. But let's say someone wants to watch a movie on Prime. If you are seeing a movie, let's say small pixel of the movie is broken, meaning like a small mini pixel in your frame of the picture is broken. Do you really care of that pixel, or you want your movie to move on, right? You want the next scene to come on. You don't care some of the pixel in your movie is gone. You don't care about it. At that time, all you're seeing is the continuation of scene to move on. You don't want your real-time traffic to go back and send the pixel again after, say, let's say, if I'm saying hello, if E is missed, you will still understand I said hello. Small fraction of a bit is missed from my hello transaction. You will still lose it, but you don't care because it is not real time. So those kind of communications are called UDP. They don't care about acknowledgements. All they want is real-time data to be transferred again. I mean, they want to be transferred in the real time. For an example, here I'm sitting here and I'm listening to maybe a broadcast radio, right? So this is signaling the data to me. I'm listening a song, right? So let's say it's sometimes you hear a distortion of the song because it's on the radio, you hear some distortion. That means that there is a packet loss. Some of the packets are being lost in the air. But do I care? Or will I move on of my song? I don't want my song to be going back in time and repetitively playing in the loop because my packet is lost. I don't care about that. All I care is whether I'm getting the song continuously or not. Even some of the words are missed. I mean, I honestly don't care about it, right? All I want is the song and it's going on pleasantly. Small disturbance. Why do I want that disturbance to be come back and sending it back to me? I don't want that. But if I am seeing something like an important PDF file, I don't want some of the part to be lost. That is very important. So until I get it, I'm going to say that I requested your file, give me the full information. So I'm going to keep on asking the acknowledgement for it. That is called TCP.
So
yes, go ahead.
Bhaiya.
Sorry. Yeah,
Yeah.
go ahead.
Yeah, Bhaiya. So like you mean to say that UDPs are negligible?
I mean to say UDP does not care about the acknowledgement. Even some packet is lost, I don't want that packet to be retransmitted again. I understand it's when you mean negligible, I gave an example that is small pixel, but it's not like that. I'm trying to say whatever the data that is transmitted in the real time is used by UDP, like voice, video, real-time data that does not need going back in time. I mean, for example, let's say you're watching an IPL game, man. You're watching an IPL game. There is some disturbance in your IPL game. Do you want to go back in time and see the same ball again? You don't care because you already know that the guy did a 2D. You already know it. Why do you want the same ball to be go back and then send the packet back again to you? You don't care about it, right? You want the next ball to be balled always. You want it to be real time. You don't want any acknowledgement. That's what I meant. The UDPs are real time. They want that real timely transmitted the data. They don't care about acknowledgements. Whereas your TCPs are very particular about the acknowledgement because it is end-to-end secure and it is end-to-end reliable in communication. Like we are talking about sending in data between one to the other file, right? What if your data you send 15 bytes of data and you get only 14 bytes of data. Your part of the file is gone and you miss some information. That means that it's no longer a valid file and we wanted the full file. That's why when you're downloading, let's say you're downloading a movie, sometimes it downloads half and it automatically fails because some data is lost. It does not make it a full file that you're gonna see. You will just see it as download failed because that full transaction never got completed. It keep on sending the data to ask for the acknowledgement and you will never get it back. So that's why you see the download failure, please try again. Those kind of messages will happen because it's all TCP. They care about acknowledgements for every packet. Sai Sri, can you tell me the difference between TCP versus UDP?
Yeah, sure. So in the transport layer, between while transmitting the data, so the TCP will actually want to know about the acknowledgement whether the each packet is transferred or not. Where it comes to the UDP, even if one packet is missed, it doesn't care. So once the data is transmitted, it will be used.
That's correct. Thank you. So as a network engineer, the session layer and presentation layers are the layers that we are not helping them to troubleshoot. These are done by other parts of the IT. So when it's a network problem, we care about physical layer, data link layer, network layer, transport layer, but we don't troubleshoot any of the session or presentation layer problems because this is all the UI that you see, like the web UI, whatever that you are seeing on the page, that's all created. That's all troubleshooted by the other engineers. But let's talk about briefly, even though we don't use them, let's talk about on a high level, what are they, right? So session layer, right? So for example, you opened cisco.com, how much time your session is opened for you versus your friend opening cisco.com. So everything is a session. So you opening cisco.com is a session and me opening cisco.com is a session. So they are part of one session. So the cisco.com server, let's try it again. So there is a person going to cisco.com. Right? So I started a session, meaning like I opened a browser and my browser started a session to reach the server. So we passed the physical layer, we passed the data link layer, we passed the network layer because the physical layer is for the cables. The data link is for layer 2, we passed that. And the server is in different subnet, Cisco, right? So we passed the layer 3 and we started it's a TCP connection because it's a reliable connection. We started as TCP. Session layer is like, okay, I came all the way to the cisco.com. Let me start a session now. So physical layer is validated, data link is validated, network is validated, transport is validated. They are all able to pass the test, right? But the session layer is when that the cisco.com knows the user came to me and let's start a keep track of the user session. And presentation layer is this server presenting the data back to you, meaning like when you open cisco.com, you will see the page. Let's say you all know facebook.com, right? So when you open the facebook.com, you will see the content. That content will be presented by the presentation layer. Like you will see the friends page, your request page, your feed, games, whatever. That is all comes under the presentation layer that you're gonna see. Application layer is all supported by network engineers because where is that? So session and presentations are done. We don't troubleshoot that. We don't dig deeper on that. It's just a high level, right? But application layer is something that is also helped by the network engineer because after viewing the Cisco page, we have to terminate the connection. Either you or cisco.com has to terminate the session. How do you terminate the session? Let's say I opened a facebook.com. How do I terminate my session? Without knowing the network knowledge, can anyone answer that? How can I terminate the facebook.com session?
I mean, you'll be going to the further step, like you'll log in, you'll be entering the login credentials so that it will be terminated there and the next step will start again, right?
Well, to an extent it is right, but I'm talking about closing the session, right? You are talking about
Log out.
Just log
different
out is
sessions in the
fine.
same. Well, even logging out, you're still on the same page. How do I? Yeah, yes, log out is an answer, but that is a stateful session. But how can I terminate it?
Clear the
History.
history.
Yeah, you will just
Clear the
close the
history.
browser. You will just close the window. You will just close the browser, right? That's what you will terminate, right? So that is called sending a reset packet. So you send a reset packet to cisco.com that you want to close the session. That is done at the application layer. So before cisco.com presenting you the data, the application can be validated by something called a firewall, which sits at the transport layer itself. So it's very confusing, but because people moved this firewall to the application layer, previously firewalls used to sit at the transport layer and identify. Let me take a step back. I want to make it very clear. So let's say there is a user here and he want to go to facebook.com. And I want to go to facebook.com on, let's say, port 80. Well, what is port 80, right? Let's talk about port 80. I don't want to move ahead on port 80, right? So let's say facebook.com is a server and it has individual ports on it, meaning like a virtual port. Think about like you are making a call to a server, but inside that server, there are multiple connections. So maybe facebook.com has one page as friends page, one page as games page, there are multiple ports out of it, right? So there are different web UI pages. Similarly, there will be multiple ports on a specific application server. So let's say I'm making the call on port 80 on that facebook.com. So I can put a firewall and I can block that port 80. But what is the problem with it? When I block port 80, all the .coms listening on the port 80 will be blocked. Maybe for example, I want to block cisco.com, but not the facebook.com. I want to allow Cisco, but block Facebook, right? So to do that, I cannot do within transport layer because transport layer does not know what application I am using. So previously, firewalls used to sit at transport layer. They don't care about what application the users are using. They just block the ports. Port 80 is blocked. All the traffic flowing on that port will be blocked at the transport layer. But engineers thought, a couple of engineers in Cisco thought that is not a good idea. So they moved out of Cisco company. They went and formed a new company called Palo Alto because they live in a place called Palo Alto in California. They built their own firewall and they named that firewall as Palo Alto because that's where their office is. Two friends who work in Cisco thought that why do we need to block every site when we can block one site at the application layer? They found their own company called Palo Alto. They work in Cisco. They thought that it's not a good idea to block at the port level. They moved out of the company. They put a new company called Palo Alto, which can block either Cisco or cisco.com or paloalto.com or facebook.com, sorry. So they can block at the application layer, not at the transport layer. So application, because of the firewall moving to the application layer, network engineers' responsibility got shifted in supporting the application layer as well, because the control is moved to application now. They does not just care about the ports, they also need to care about the applications, whether we want to allow them or deny them. Well, engineers in India, outside of US, they don't work in different domains, because when they are a network engineer, they just work on few things. But in US markets, in US companies, they want you to know different technologies. They don't give you work on one specific technology, and they don't restrict you in one vendor, right? So that is both boon and curse, right? You will know more working here in US, but at the same time you have to understand different technologies well. So that is what about the application layer, honestly. So we are moving the firewall to the application. That's why the responsibility changed for an engineer to know more about application, because the firewall sits at the application layer, and we are blocking the sites at the application layer, not at the transport layer, just not blocking the ports. That is it. Hari Prasad, can you tell me why do we care about application layer?
Because like we don't want to stop at the transport layer, right?
What do we want it to stop?
Like we don't want to stop the firewall at the transport layer, so we need the application layer to terminate individually.
Yeah, correct. So we wanted to have more control of the traffic. So whether we want to allow or deny the traffic, that's why we were understanding more about the application layer, like what to allow, what not to allow. We'll have more control in the application layer than the transport layer, not just blocking at the port level.
Yeah.
So that's basically 7 layers of OSI that will help you to identify where the problem is and how we can identify the problem. Because let's say you are a physical layer engineer who does not know anything about networking, you know only about cables. What you're gonna do is, hey Ravi, I checked all the cables from PCA to PCB. I checked physical layer. Every cable is connected. There is no physical layer issue. My job is done. Can you ask the data link engineer to validate that if he sees any issue, right? So to make the work easy, to make sure that we were able to identify the problem, the OSI layer is designed just to make our lives easy and the engineers' lives easy. So that is about OSI. I'll stop there.
I have a doubt, like when you say port number, is that assigned the moment when we open a browser or a tab, or how it is, generated?
Well, when you open a facebook.com, do you really make that call? No, right? You as a user does not know. You don't know what port you are hitting, but who is deciding that, right? Who is actually deciding that is when you make the request. Let's go back to the, who asked this question?
Aruna.
Aruna, okay. So Aruna, so you are sitting in your home, you open google.com. So you open your web browser and you type google.com, right? So you type it there. So what will happen is, first thing, you will check, your packet will be sent to your router. And the router will be validating the destination, right?
Yeah.
And that will be sending the response back with a TCP handshake. But with knowingly or without knowingly, you are doing a call called HTTPS. Have you seen this?
Yes, yeah.
And this means that you are using 443 port.
Okay.
You don't know that you are doing that port, but you specified
Mm.
HTTPS as your application. That means that you are using 443 port. But what if you used HTTP instead of HTTPS? That is using port 80.
Okay. Oh, okay.
So you are making that call. You are making that call as port 80, but you don't know that. That's it.
Okay. Okay.
Good question. Okay.
So I have a doubt. So what the application layer does, like what's the basic functionality of
So the basic functionality of application is to make sure that all the data that the customer requested is given back to the customer in a meaningful way. So I told you the presentation layer will give you the actual presentation, the look and feel of the web UI that you are looking for will be presented in the presentation layer. The application layer will fine tune that. So the request started, the request ended, the application started, the application ended. So there are different requests. Again, HTTP GET request, HTTP push request, HTTP reset request. There is different requests there in the application layer. So that will take care of the start and end of the application, the data that you are seeing. Just to put it in a simple way, it will control the data that you are wanting to see, when to start, when to stop. That will be taken care at the application layer. When, for example, sometimes when there is no internet connection, you might have seen 404 error, or there might be a small dinosaur running saying that there is no internet connection, right? You might have all seen that. So that is also an application response coming that you don't have any internet connection. So that is also a small application that request 404 is not found. I cannot answer that in detail because you guys are not ready yet. But when we go a little bit deeper, I'm sure that you will understand more about the application layer. But for now, think that it will be providing a framework to make sure that you get your request right at the app layer. Like, for example, if in your application, like Facebook, the application layer will make sure that it presents you the data the way you want it. Is that clear, or do
yeah,
you?
it is clear. It is clear. Thank you.
Okay. Yeah, I'm sure I did not answer that well, but I'll promise you that when you are moving into the course, you will get more clarity on that. I think, yeah, that's enough for today. I think we did more than what I thought. Let's see. Kolla Manogna, can you tell me what is a physical layer?
So if there is a network, or else if there is a connection established in between two servers, for suppose, so if there is any connectivity issue, like with the layer of the connection physically, so that where comes the physical layer.
Okay, thank you. Good. Okay, fine. I think we are okay. I'm going to give 7 minutes to ask any questions. If you don't have any questions, you are free to drop. If you have any questions, you have 7 minutes to ask. It's up to you guys.
No, I think.
Yeah, you can also give your feedback if you want any changes or anything. Let me stop this recording first. 1 second.